Hi, this is Sandeep. So today we'll be talking about NHST, Null Hypothesis Significance Testing. Okay, so these are the step for Null Hypothesis Significance Testing. Starting with first, we'll state the alternative hypothesis. Okay, first, second is then null hypothesis. Then we'll fix alpha, fix power, we'll estimate the effect size. Okay, we'll talk about all the steps slowly. Okay, then we calculate the required sample size, we collect data, analyze, interpret, then conclude. Okay, so these steps are like, first we'll check the hypothesis, which is alternative hypothesis for our research. Okay, for example, we are checking Brahmri improves concentration. Okay, then we state the null hypothesis. The null hypothesis, like first alternative is Brahmri improves memory. Okay, when we state null hypothesis, it's just opposite of alternative. We say Brahmri does not improve, okay, memory. Simple. Then we'll fix alpha. Okay, one, these are the standard values. Okay, it tells about like our research may have only, if we take this value, so only just 5% of error. Okay, like we can deal with 5% of error or 1% or 0.1% of error. Okay, that's tell the value of alpha. Power is like, okay, how much power we have. For example, when we do elections, okay, the more the person, the candidate having more votes got the seat. The same here, we should have at least 80% power or 95 or 99% power. Okay, we set any of these values. Okay, then we estimate the effect size. Okay, effect size like how much the amplitude or magnitude of the changes. Then we calculate sample, like how much sample size we require. We collect data, then analyze, and then conclude. Conclude means like we say either we accept the null hypothesis or we reject. Okay, accept here it is called fail to reject. Okay, coming to next. Okay, talking about hypothesis and null hypothesis. Okay, as I said, a statement that conveys the anticipated outcome. Okay, what we are thinking, what our result should be, it tells about that. For example, same Brahmari pranayama changes memory. Okay, and the null hypothesis, a statement that negates, okay, the important point, that negates the statement of hypothesis. So here we go for opposite. Brahmari pranayama does not changes memory. Simple. Okay, coming to next. So there are two types of null hypothesis, either, or hypothesis we can say simple, one tail or two tail. Okay, so types is like one tail and two tail. So one tail is like when we say the research or the question is moving only in one direction. Okay, so one direction here means like when we are saying Brahmari pranayama improves memory. Improves means it's increasing it. Okay, now I'll tell about two tail. So two tails is like, here it's written Brahmari pranayama changes memory. Okay, so here change word means like it can increase or it can decrease. Okay, we don't know, it can go either way. So that's why it's called two tail, where there is a possibility of changing or going to any direction. That's called two tail. And here we are saying only improves in one tail, that means it's increasing. Okay, that's one tail. Okay, hope you got this simple concept. Now we'll go for types of error. Okay, there's two types of error, type 1, type 2. Okay, let's see this scenario here. So here it's given the nature of hypothesis, null hypothesis, okay, and here what the researchers claim or decide, okay. For example, assume the research is true. You are taking an example of Bhramri pranayama improves memory, okay, improves memory. That's our null hypothesis. Let's suppose. So we are saying here this first one, okay, this first one we are saying, we are assuming that Bhramri pranayama improves memory, but researcher reject is, okay, researcher say no, Bhramri pranayama does not increasing memory or improving memory, okay, but we assume that it's true. So here he has overestimated the research, okay, that's called type 1 error, okay. When the research is true but by any means researcher reject it, that's called type 1 error, okay. Second, we say the research is false, okay, like Bhramri pranayama, let's suppose now, does not improves memory, we say, okay. So research is false means Bhramri pranayama does not improves memory, okay, but researcher by any means say no, it's improving memory, okay. So it's going opposite, he's underestimating the research. That's called type 2 error. When research is wrong but by any means researchers accept it or fail to reject, that's called type 2. And when research is true but researcher reject it, that's called type 1 error, okay. And when these are the different conditions, when research is wrong and yes researcher reject, that's called the power sensitivity given by 1 minus beta. And when research is true and researcher accept or fail to reject, that's called specificity, okay. So these are two error and these are two specific conditions, okay. Let's go for next. Simple. Alpha is 1, rejecting a null hypothesis when it's true, okay, and beta is failing to reject means accept a null hypothesis when it false, okay. I think you got these. Power we call when we reject the null hypothesis when it's false. Specificity, we accept or fail to reject a null hypothesis when it's true. Simple, okay. Now we'll talk about effect size, okay. So effect size is simply a magnitude, okay, of an interventional effect measured by measuring variable. In a simple language we say when we do any research, okay, so how much effect it's showing, okay, when we collect data pre and post, we'll get the changes we got, okay. So by that mean and standard deviation we can calculate the magnitude of the effect, okay, how much effect it's giving to a research, to the variables, that's called effect size, okay. It can be obtained from mean, standard deviation, Cohen's d, or pilot study, okay. These are the different forms. So some standard values, Cohen norms are set, okay, like we'll get the values if we get like between 0.5 to 0.8, it's called moderate, okay. Above 0.8 it's high, and below 0.5 below, yes, 0.3, around 0.3 it's low. And same in for the correlational study, Cohen's norm is high 0.5, moderate 0.3, low 0.1. These are the standard values, okay. But if you're getting these value, we can like decide how much effect it's showing, either low, moderate, or high, okay. Simple. Now we'll talk about sample size calculation, okay. So sample size, why do we need sample, okay, to collect data we need some persons, okay, some people, some sample. So we should know like how much we need, okay, either 10, 20, 40, 100,000, how much should we need, okay. That's why we calculate sample size, okay. So in definition, it's the number of participants need for the study to show the expected effect with minimum and adequate power, okay. Now it's done before study. So we calculate by using alpha, effect size, power and tail, okay. Alpha, like, okay, you all know the, here we have talked about alpha is like 0.05, power let we take 0.8 mostly, effect size, whatever the effect size we calculate, or we use this number from the previous paper for the same variable of research, like which are matching one. So we use the effect size from there. And tail we mostly use 2 tail, it can be go either way, okay. So we put all these values in a software called G power, okay, and then it's give the required sample size. For example, like here, okay, I've took this screenshot. So here you are saying tails, okay, we have tail. This is the effect size from a particular paper, it's very high, 2.3. Alpha is 0.05, power is 0.9, okay. So these 4 values we have to put, and then after calculating we'll get our sample size, okay. So here it's showing 7, okay, one group 7, second group 7, total 14, okay. That's a G power software, simple. Now p value, okay. So p value is simply null hypothesis, simply tell about the probability of getting the null hypothesis, okay. These are together, null hypothesis is true, okay. It's just tell the probability, okay. So p value is less than alpha, okay. If it's less than alpha we reject, and if it's greater or equal to alpha we fail to reject. It's normally set to 0.05, okay. If p value is less than 0.05 we reject, greater than or equal to 0.05 we fail to reject, okay, simple. Normally we take this particular value, we have these 3 other 2 also, okay. So that's all for today, thank you so much, okay. Today we have discussed p value, G power, sample size calculation, how to do effect size, errors, okay, types of error, type 1, type 2, how it's overestimated, how it's underestimated, okay. We talk about types, 1 tail, 2 tail, hypothesis, null hypothesis, and the whole steps of null hypothesis significance testing, okay. So that's all for today. We'll talk about sampling techniques in the next video, okay. Thank you.